For this problem, we're given a scenario where we have a tower guy wire. It's anchored by a bolt at point A, and the tension in the wire AB is known to be 2,500 newtons. We're asked to find the components in the X, Y, and Z axes for the force acting on the bolt. And then, of course, the angles that define the direction. So what we'll do is we'll start by looking at the geometry, and we'll determine what the direction is for d sub x, d sub y, and d sub z. So d sub x is from A to the center of the tower. It is 40, but it is to the left point A, so it is minus 40 meters. D sub y is from A over, or rather up, 80 meters. D sub z is 30 meters. All right, so we know the dimensions A, Y, and Z for our vector. That's going to define what's happening in the guy wire AB. So knowing those, we can then solve for the distance, or AB. So AB, our distance, actually equals the square root of dx squared plus dy squared plus dz squared. So that equals minus 40 meters squared, 80 meters squared. All right. Okay. All right, 1,600 plus 6,400, that's 8,000. 8,000 plus 900 is 8,900. And that equals square root of 8,900. That's 94.3. Okay, so we know D. Knowing D now is 94.3. Now we can look at the components in the X, Y, and Z axes. So we know the unit vector, which is described by the proportions, and the distance from B to the top of the guide tower is defined by minus 40 meters I direction plus 80 meters J direction plus 30 meters times K direction. Okay. So our unit vector lambda equals our unit vector AB over AB. And we know that the force can be expressed in terms of the unit vector AB. So we know that the force equals F times lambda, and that equals F times AB, unit vector over AB. What does that mean? That means 2,500 newtons that's our force in AB, over 94.3 times our unit vector AB. And now to solve for the X, Y, and Z directions, what we'll do is we'll take our 2,500 newtons over 94.3 times minus 40 meters I plus 80 meters J plus 30 meters in the K direction. And this will give us our components in each direction. So we wind up with negative 1060 newtons in the I direction. That's 2,120 newtons in the J direction. And 795 newtons in the K direction. So f of x, therefore, equals negative 1060 newtons, f's of y, 2,120 newtons, and f's of z, 795 newtons. And so now we need to calculate the direction of the forces. And so what we'll do is we'll go back to our sketch and we'll look at our angular measurements. So we know that for the y-axis, we have one angle. For the x-axis, we have another angle. And then the distance for the z-axis is yet another angle. So we know the value for f of x and we know the value of f. So if we know those two, we know that the cosine of theta x equals f of x over f, or negative 1,060 newtons over our 2,500 newtons. And then we know our cosine of theta y equals f of y over f. And we know that is 12,120 over 2,500 newtons. And then in the z direction, again, same process. We know that cosine theta z equals f of z over f, and that equals 795 newtons over 2,500. So we have those values. We'll do the inverse cosine, and we'll solve for our angles, and we'll find that theta x equals 115 degrees. Theta y equals 32 degrees. And theta z equals 71.5 degrees. So we've now solved a practical problem where we looked at it in 3 dimensions.